We want to determine the intervals in which the piecewise function is continuous. One way to do this is to graph it and then visually see where it's not continuous, but another way is to look at it algebraically. One thing to notice is that there is no value defined at x equals -2. Here it's strictly less than -2, and here it's strictly greater than -2. So definitely x equals -2 is not going to be continuous. Now, the function y equals 2 is continuous everywhere in general, but x over x plus 1 is a rational function, and we know that it's not continuous at x equals -1. Because here, at x equals -1, we get a vertical asymptote. So everywhere else, it's going to be continuous. So if I look at the graph, I do not want to include -2 and -1. So I'm coming in from the left here. I'm coming in from negative infinity. I'm going to stop at -2, but I'm not going to include it. And then I'm going to go from -2 to -1, making sure not to include the endpoints, and then going from -1 to infinity. So this is the answer to part A. Now for part B, determine whether each discontinuity of f is removable. So we said that there's 2 points at which f is not continuous. So at -2 and -1. At -1, that's going to be an asymptote. So it's going to look something like this. So you can't just put in a point there and make it continuous. It's not going to happen at -1. But it's interesting at -2. Well, we know when x is less than -2, it's going to be 2. So that's going to be a hole there. And then when you plug in x equals -2 into this second function, you get -2 over -2 plus 1, and this is just going to be +2. Okay. So they're both going to have the same value at x equals -2, but it's not going to be filled in because it's strictly less than or greater than. X cannot equal -2. So you're going to have a hole here, and it's going to go all the way up to the asymptote there. And then on the bottom here like this. But we're interested only at x equals -2. And if we were to plug this, or if we were to fill this in, we would see that the function will be continuous at x equals -2. So we call this type of discontinuity a removable discontinuity. Okay, so x equals -2 is removable, and x equals -1 is not removable. And that's our answer to part B.